Alright guys, we're going to do this example here. Um, and what I'd like for you to do is actually to pause the video, try to sketch the possible graph, and then when you've sketched what you think satisfies those conditions, unpause the video and then follow along with me to see how your solution fared. Okay, so the conditions that are given, condition 1 says that the first derivative is positive on the interval negative infinity to 1, and the first derivative is negative on the interval 1 to infinity. So from the last section, we know that the function is decreasing from 1 to infinity, so we can mark that. The function is, its derivative is less than 0, so the function is decreasing in this section. And the other condition was that from negative infinity to 1, the derivative was positive, so here we have the function is increasing in that region. As for the second derivative test, we can see that the function is concave up from negative infinity to negative 2. So we're concave up there. Which looks like that. And we're also concave up from 2 to infinity. So I'm going to mark that as well. So there we go. It looks like that. And then in the middle, we're concave down. And the last set of conditions say that as x approaches negative infinity, the function approaches negative 2, and as x approaches infinity, the function approaches 0. So this means that there are asymptotes. So there's a horizontal asymptote at negative 2 when the function is approaching negative infinity, and there's a horizontal asymptote at 0 when the function is approaching positive infinity. So we can use all of that information to help us draw a sketch. We know the function should be increasing from negative infinity to 1, and we have a point of inflection at negative 2. So I'm going to draw that in here. I should have a point of inflection here, and then I should have another point of inflection where I change concavity. Points of inflection are a change in concavity, so I was switching from concave up to concave down between these two regions, and I'm switching from concave down to concave up between those two regions. So negative 2 and 2 are points of inflection. Okay, so I need to be increasing. I know I'm going to start down here because the function has a horizontal asymptote as x approaches negative infinity here. And I need to be increasing in this region all the way to 1. I'm increasing all the way to 1. So I'm going to start increasing, and I'm concave up, so I'm going to increase by going concave up. And then by the time I hit negative 2, I need to be switching to concave down, but I'm still increasing. And then when I hit negative 1, or sorry, when I hit 1, now the function's supposed to be decreasing, but I'm still concave down. And then I have a point of inflection at 2 where I'm concave up. So I'm going to be like that and approach my other asymptote that was approaching 0 as x goes to infinity. So there's a rough sketch of what this graph could look like, and we can see that we had a maximum at 1, because that's where the derivative of the function switched from positive to negative. So it would be equal to 0, so there's a max there. And we can see our point of inflections here, where we switched from concave up to concave down, and then back from concave down to concave up. And we've satisfied both of our end behavior. Negative end behavior was that it should approach -2, and our positive end behavior, the function should approach 0. So there's one possible sketch